Good evening, everyone. Hope you had a good week and a good day. Let's start with data analysis. Before I start, just want to confirm everyone's here except for Rita and Olafemi. And then we have Naifu Aishat. Can you confirm if you're supposed to be in this Zoom call? If not, I'm going to remove you in the next 5 seconds if you don't respond. 5, 4, 2, 1. All right. I'm going to kick them. All right, that's fine. Can everyone hear me loud and clear, guys?
Yes, we can.
Thank you. And I just noticed a mistake I made on this. It's not lecture 1, it's lecture 2. Anyway, welcome back. So the agenda for today will be homework review, complete the fundamentals of data, the recap, and the final stages, and then start with descriptive statistics. And then I'll talk to you about your project work. Is everyone okay with that one? I hope. I mean, yes, it should be. The one thing that I want to try and talk about is something we spoke about last week. I know when I was going through, when I gave you the homework, some people thought that I was going too quickly and then asking you to do the work when I didn't teach you anything about it. So ideally, I was expecting everyone to have some sort of statistical knowledge, not any knowledge with Python, Google Sheets, Excel, but general knowledge about finding out mean, max, and averages and everything else. But that's completely fine. I was wrong. I should have confirmed it with everyone before I started it. And by the way, we made a joke about how I would teach you easy stuff and expect you to do difficult stuff. That's how it will always be. When I say it will be difficult to do your homework, it will not be impossible. You can do it, but it will take you some time and some effort. So, for example, I can teach you what's 1 plus 2 plus 3 and say it's 6. But then I expect you to do something harder, like what's 5 plus 6 plus 8 plus 10 plus 25. You can't do it in your head, but if you sit down, write it down, or go through it, you should be able to do it. By the way, if you guys don't know or are stuck on anything, please feel free to message me. Before we start, I just want to show everyone how Discord works. So yeah, and when we go to Discord, and let me just change the server settings so I can access it as a. I can access it as your group, so you don't have to see everyone's thing. So if you go to the batch Ryan. So when you go, this is the screen that you will be seeing. And then general is something that you can talk to when you have next batch of students join the call. Random is just where you can post memes just to try and get some social interaction going on within friends and within colleagues. Advice is when we will start from week 4, week 5 onwards. Whenever I learn something new or find something new, I'll just add it here. Job alerts is something that we can start from week 16 onwards. So whenever we get any jobs or any new opportunities, I will just paste the link here and then we can start working on the CV and cover letter for those. And then that's a general channel that's shared with everyone. Batch Orion is what you 8 can see. I mean, including Rita, who can't join us today, but everyone else. And the announcement is purely for me and Ola to post. All the messages, all the updates will be done here. And then my message will always be the same. You will have a lecture recording right at the beginning, followed by the homework, and then any other extra information that you should know. And I hope Ola will follow the same format. Introductions is something that I want everyone to do, because if you don't do this one, that means you have no interest in with your colleagues and you're not interacting with them. That's not a good thing. So please try and finish the details over here. Yeah, thank you, Emmanuel. When I say introductions, is just a full paragraph explaining who you are, what you want to do, and everything else. You don't need to do it right now. And discussion is what some people have been using pretty well. If you have any questions, just post it there. And if you have any urgent messages, you can ping me. way you can ping is use the at symbol and write anyone's name. Like if I know Olafemi is not here, so I can just ping him and say, "Where are you? Are you joining the class?" So use discussion for purely messages and trying to grab my attention. Portfolio projects is when you will be starting from week 6 and 8 onwards. So whenever you create something, you can add it here, add a link to your GitHub page or Git page, and then we can look at it and we can tell you what's wrong or what can you improve, etc. You get live feedback. And again, feedback is where you can try and add information there and give me feedback on how to improve. For example, I know Bola felt like I was going too quickly and asking her impossible questions. If you think that's happening, add it here. And today, because I will be doing a recap on all the statistical foundations, you might think I'm going a bit too slow. Add a feedback here saying, "Oh, Vijay, you're going too slow. Can you speed up for next lesson? Or Vijay, can you give me more work so we can practice it, etc." And then yeah, Hangout is just a normal call if you want to talk to your colleagues, but very quickly. So if someone messages you on discussion and you can't follow up on what they're doing, join the Hangout with each other and talk to them. Anyone can join. It can take up to 9 people or 10 people, I think. And then trainee is something that I'm in charge of. So if I go there, I can join it, and then I can drag anyone into it. For example, I can drag Emmanuel. I can drag Emmanuel. I can't, but yeah, I can try and add them in there. But that's it. Yes, Efe, you have a question?
Yes, please.
Yes, go ahead.
So on the thing, the Hangout, can we
Yes,
share a screen there? If
yes, you can
say,
share your screens there.
right, okay, thank you.
So yeah, I want you guys to use Discord. And yes, you can message me on WhatsApp as well, but I prefer to use Discord. I don't use my WhatsApp as often because when I work, I leave my phone on my table and I just go around talking to my colleagues and doing some experimental work. So I might not respond very quickly. I think Bolo must have experienced my delay in messages there. But yeah, when you send me a message on Discord, I'll try and be quick about it. Anyway,
Okay.
yes. Don't worry, I don't mind if you're sending me a message on WhatsApp. It just if you want instant response quickly, you can use Discord. And if I can't answer it, someone else can try and answer it for you. Because we are, as a group, we are a community that have to work together. And I know the same thing happened in WhatsApp as well. I believe Emmanuel asked a question and someone else answered it. I'm trying to go back on this one. Oh, well, it's fine. I've seen that someone else answered it as well. Ayodeji answered it. Yeah, there we go. When Emmanuel asked to try and help each other, guys, try and let's work together because when we start doing projects, you'll be working as a group and it'll be nice for you guys to know each other before that rather than forcing yourself to find out about each other on that day or on that period. Anyway, let's go with the homeworks. So data analysis task 1, let me open that up. So yeah, let's go with the first one to finish the homework. FA is the first one to finish the homework that I've seen. That's all right. Yeah. Very good. You followed everything that I explained in the homework session. You did that's, yeah. Did you, so when you're doing this one, did you copy it, FA, or did you do something else? Because if you're doing it correctly, you should be using functions in these stages. Like 72 is not 72, it should be equal to maximum of it. And that should be min of it. Oops. I'll look at the Discord message afterwards. Okay, ignoring that one, everything else seems like you copied the numbers. Is that how you've done it, FA?
Okay, yeah. So I did it on a separate Google Share
Mm-hmm.
and then copied it down to this place.
Oh, okay, that's fine then. That's completely fine. And then yeah, nicely done. And then you tried to talk about the standard deviation. You said considering the distribution of mean, standard deviation shows higher potential for sunflower yield to be the feed to yield better result. Standard deviation. Oops, I can't. control this thing. What standard deviation does is it shows you the spread of the data, like how far away it is or how close it is. But the spread doesn't show if it's a better yield or not. I think you misunderstood the standard deviation explanation there. I will try and cover it again this week, so it makes more sense. But a
Okay.
good attempt at using a graph. I like how you try to do the average rate, min, and max in the graph, but I'm sure there's a better way of doing it. Do you have any idea on what's the better way to do this?
No.
No? Okay. So if I were to compare the average rates between casein and sunflower, is it easy to see the differences there?
Okay.
It's not easy,
Yeah.
it's too far away. So the grouping should be, in a sense, you're doing all the average rates in one group, all the minimum rates, and all the maximum rates, because you're comparing between data sets. So your statistical measures should be in the same grouping rather than all the measures, no, all the data sets and your statistical measures should be in the same grouping rather than having statistical measures for each data set or each field individually. So I know for when you're looking at meat meal and soybean, looking at the min value, we know the soybean has a higher value, but is it easy to see that?
Okay.
It's not, but if you do it in a different way, it's nice. Again, it's a good attempt because you went further and beyond to add this graph. So nicely done, nicely done. Good work.
So what are you trying to say is I would have done a chart for the mean separately, the average separately for each feed, right?
Yes, that's correct. If you can do it that way, that would be perfect.
Okay.
If you want, you can do a grouped bar chart in the same one as well. So you can have a mean and all have all six bars together. You can have min 6 bars over here, and then max 6 bars over there. That works too.
Okay. Thank you.
Yeah. But again, you went above and what I asked you, so that's very good work. Next one is Bola. Again, same thing. Over here, you actually use the functions. Nicely done. And then yes, I noticed that I forgot to include any duplicate rows in the data set I shared with everyone else. I should have done that, but that's why no one has any duplicate rows. So that's fine. Good news. Carrying on, good explanation. And the idea that because the average, min, and max are higher in sunflower, you're choosing sunflower. That's very good. And your explanation over there is correct. But oh my God, I can't use the sensitivity for the scrolling. If you go over here and look at this value, does sunflower actually have the highest values in everything? It it actually does. Ignore me. Ignore me. You're completely right. Sorry about that, Bola. Nicely done. And then yeah, again, nice use of using a graph, but you should don't use a line graph to compare categories because the line graph shows a trend. Over here, not showing a trend. You're trying to compare them. So a bar graph would have been a better approach here.
Okay.
Yep. But again, I didn't teach you or go over line graphs and bar graphs, but you trying this is very good news. Because you tried it, you learned that you have to use a line graph for continuous data or numerical, not continuous data, not for uh categories. So that's very good. Let's go over to other works. Rita's not here, but yeah, whenever I do anything, I'll add these red notes explaining what could have changed and what could have been better. And if you don't understand what my notes are, send me a message on Discord. Oh yeah, Valentine or Valley B, you didn't do your work?
Yeah, I did my work, but I didn't know how to submit it.
Had to
So
submit it.
let me just I did it in Excel. Let me just copy it to Google Sheet, then I'll forward the link in chat now.
Okay, that's fine. No rush, no
Yeah.
rush.
Okay.
Olafemi, yes, you got the nice ones. You gave me numerical data. So just saying single word answers, but no, don't make it a habit to do that. Make sure you give me full sentences. I want you to get used to explaining yourself. If you're giving me single word answers, it's like giving me question and answers from your school level. That's not what we are learning here. All right.
It likewise.
Sorry, Valentine, what did you say?
Yeah, I did explain because I didn't look at the video, the previous lecture because I didn't see it. So I just did it
That's
often,
fine.
like, so I didn't really explain all those things. But let me try to copy it. Send the link now.
That's fine. No rush, Valley B. You can just add it when at your own time, and then we can go over it. Again, as people made it clear that I was rushing myself a bit last week, so I expect to see some issues over here anyway. Let's look at Amos. You did the same thing. You just did
Sorry,
the
I submitted my
explanation.
assignment.
Sorry, Manuel, what did you say?
I actually submitted mine on the portal, yeah?
I don't see it here. Let me
You
refresh
you know,
this.
there's a place for submission, yeah? I just went there and submitted. Oh, maybe I did the wrong
I
thing.
think you've just done that in Ola's assignment because
Mm.
Ola's assignment says add submission.
Okay, so can I add it here? Because I have the assignment here. How do I submit from here then?
So I sent you the link in the meeting chat. You
Okay.
can open this link.
Hmm.
When you open it, you'll come to this page.
Okay. All right then.
Oh, Rita just changed the answers. That's fine. I'll look after that one. But if you go there, you can click on your Emmanuel's homework and then add your information there.
All right, let me try that now.
But again, no rush because I'll try and quickly go over this and then go through the actual work afterwards. Yes, FA. Go on, what's the question?
So because the last class, I know you mentioned something about the standard deviation that if it's small or something. So I don't know if you can go through that bit again,
Yes, I will go over that again.
please. Thank you.
Yes, Ayodeji. You've done this separately. I didn't look at this one till now. Sunflower is the best seed. Have confidence in sunflower because its standard deviation is the second lowest, which is 48 with the highest average. Yeah, that's an acceptable answer, but make sure you explain that it has the highest values in every single field. That's why it's good. Because you skipped the first step and you went to the second step, which is explaining the standard deviation. Okay, try and keep the story going clearly, saying the sunflower seeds has the highest values in every single one of them, mean, max, min, and the standard deviation is the second clue, so that means you can expect to get good results from them. But yeah, good use of standard deviation explanation here. All right. Is there anyone else's homework that I forgot that I need to go over quickly? Or is it fine if I send you
No, I
guys?
can't find any link. Is there a way I can submit here?
You can't, can you not see the meeting chat? Oh, why is this not showing?
I don't know where the meeting chat is. I don't know.
You don't know where the meeting chat is.
The meeting chat.
I will send it in.
No, I'm not conversant with Discord so I'm just struggling with it really.
It's not a Discord, it's in the how do I explain this? In the Zoom meeting chat. Do you know where the Zoom's chat
The
is?
link, yeah, I've copied the link and pasted it and it brought me here.
But I can't see your screen. Can you how about this? Do you want to post a picture in discussions? And then we can go from there. Again, don't worry, I'm not annoyed about this or anything else. It's all good.
I just paste mine on the message box.
Is that you?
Can you?
Is this your one?
Yes.
Oh, you answered you used someone else's work, Valley B. Over here, I wrote your name as Valentine.
Yeah, whichever.
Yeah, I mean, this is someone else's homework page. So don't paste it there, if that makes,
Oh, oh,
yeah,
sorry.
because it's submitted under someone else's name. That's fine, that's fine. We can clear this up afterwards.
Okay.
Again, so I explained this over here. You changed that one. And yeah, you changed everything there clearly. That's nice. Good. All right, let's go back to the presentation. And Emmanuel, if you still can't do it, just send me a message on Discord, and when you're free tomorrow, I'll show you how to do it. Is that fine?
All right, no worries.
Perfect. All right, that's good, guys. And I also went to the second homework, which is to understand the difference between normalize and standardize. Anyone wants to take a shot at this and try and explain to me what's the difference and when to use it and when you shouldn't use it? Any volunteers?
Sorry, I didn't get that. Sorry.
So last week I gave you 2 homeworks. One of them is to finish the data analysis task 1. And the second one is to try and understand the difference between normalizing data and standardizing data.
No. I didn't remember that. I didn't remember this one.
Didn't remember? Okay. Anyone
Yeah.
else want to take a shot? Because in the announcements, it's written right there. What is the difference between normalizing and standardizing data? Where and why you should use it, where and why you should not use it. Again, there are no wrong answers here, so that's fine. So anyone wants to take a chance? Because what I want to make everyone aware of is data analysis is not just about doing analysis and getting the result. You have to try and understand why you're doing why you're doing the analysis and explain what the result is. If I say the mean is 1, what does that mean? It's not enough. All right. So who wants to try and explain the difference between normalize and standardize? What you should use it for, what you shouldn't use it for?
Like from what I read or from my own research,
Yep.
I would say that standardization is got no range restrictions. Like it centers around a mean of 0 and the standard deviation of 1. While the normalization is got a range, which is often between 0 and which is often 0 and then 1.
Mm-hmm.
Okay, so and I think you can use I think when you want to predict something, you can standardization applies. I don't know if I'm right, but I think that's what I can summarize from what I read. Yeah. Like when you want to predict something, predictions about data or something, the data distribution, then standardization can be applied.
Good attempt, because predictions or something is something that I've tried to explain last week, and you try to explain that in your own way. So good attempt, FA. But that's not quite the answer. Yeah. In the context of time, I would try and speed up because I actually did go through this. So first things first, normalizing is it's a scaling method where all the data points are shifted and rescaled. For example, this is the equation that you use, where the new data that is from 0 to 1, you get it by using the old data, and then you take away the minimum data from it, and then divide it by the range. So it's used to compare two unequal data sets. I do have an example. I'll come back to this one afterwards. Standardize is also another scaling method where the data is centered around mean and standard deviation, because that's what you use in the equations. Mu is the mean, sigma is the standard deviation, and you'll get this normal distribution graph where the one standard deviation away from the mean contains around 68% of the data set. 2 standard deviations away from the mean, from here to here, contains 95% of the data set. 3 standard deviations away from each other contains 99% of the data set. So you're just saying how close is the data to the mean. If it's like 1 standard deviation away, it's in the general population. If it's 2 standard deviation away, it's quite unique. Have you guys seen IQ graphs? How does it look like? IQ charts look like a bell curve, And then if you have a high IQ of like 130 or 140, you're in this range, saying you're quite smart. If you have a low IQ of 90 or 80, you're on the left-hand side saying you're not as smart, but you need to work hard. That's what it says. So standardizing is a different method to scale the data, make it more understandable. Let's see. And you can also use standardize to remove outliers. When I say outliers, what does it mean? Anyone wants to try and take a shot at that one? What is an outlier? All right. The silence is quite scary. Emmanuel, do you want to try and answer this? You said you are a data scientist or data science student. What is an outlier? No?
Hello.
Hello, Emmanuel.
Yeah. So, I've submitted my assignment to you. I used the email address.
Okay,
You can check now and see if you got it so that I can be sure.
I can do that in 2 seconds for you. By the way, anyone wants to explain what an outlier is in that time period? If not, Emmanuel will have to explain it because he spoke.
Basically, an outlier is just it's like an abno it's it- okay, so if you're doing the what is it called? There's this, honestly, I can't remember much anymore. But basically it's like how like an overlapping.
Yeah.
That's the way I can explain it. It's like an overlapping in data, you know. Usually, like if you take random samples,
Mm-hmm.
uh, uh you have some how will I put it? If you plot your graph here,
Yep.
you'll find some, data going outside the line, if that makes any sense. That is, so at that point you can say yes, these are like outliers. That's the way I understand it. Like if you take
Okay.
random samples, so you see them like maybe at very, very funny kind of distances, like abnormal,
Mm-hmm.
distances, that kind of stuff, far away from the norm, from where I don't know if I'm making any sense. But you get what I'm trying to say. If you do it on the graph, on that, the graph I'm talking about, I don't know.
Yes, I understand what you're
Yeah,
saying because,
yeah.
and I
That's
know
how
where you're
best I
coming
can
from.
explain it. Yeah, that's how best I can explain it. But I
Yep.
can draw it. I can, draw it. I can explain it with a drawing. I don't know if that'll be good.
Uh, that's fine. We can talk about that one afterwards in terms of using
So
graph.
have you seen my assignment?
Yes, I've got it, but I'm going to look at it after the call, not right now.
Oh, all right. Thank you.
I do have the email. Yes. So yeah, outlier. I'll try and explain it in a very simple way. It's a data that doesn't fit with a normal with a distribution. Let's say you buy a packet of crisps, and then you get, let's say, 25 crisps every single time you buy it. Well, you won't actually get 25, you get 25, 20, 15, or 20, 30, 35. But one day when you open a crisp and you get 0 crisps inside it, it's full of air like Lace or Walkers. That's an outlier because it's not something that happens normally. It's something that's like a one-off, very extreme data. That's what an outlier is. It's an extreme data that doesn't fit within the normal distribution.
Yeah, can you please use another example to
So
explain?
not a crisp then. Let's say you went to a school and you went to a fifth class student. What's the height of a fifth class student or year 5 student? They're all roughly a meter tall or 1.2 meters. But if you see someone that's like 1.7 meters there, he's an outlier because he doesn't fit in within a fifth class height limit. Does that make sense? It's an extreme data that
Yeah,
doesn't fit with the general trend.
Yeah.
Yeah, so for example, I'm showing you a data over here, 134642324 299. Over here, what's an outlier? 299 is an outlier because it's an extreme data set. It doesn't fit in with the norm. So if you look at the remaining data, you can see that they should roughly fall between 1 and 6. That's what makes sense. But if you get 299, that means someone wrote it incorrectly, someone mistyped it. And this is something that you will see a lot when you get your data sets. Okay, going on. When you use a normalizing equation, which is the x old minus x min divided by x max minus x min, you'll get 0, 0.01, 0.01, etc. All this data is very, very tiny and it doesn't make sense. And there's a huge jump to 1. But because we're only dealing with 10 data points here, you can see it. But imagine you're dealing with 1,000 or 10,000 data points. Are you going to scroll down each of every scroll through every single one to see why all the values are small? And do you try and arrange it and try and look at it? That could work, but it's not a sustainable method. So what you can do is you can use the standardized metric. When you do that, you get all the data over here is minus 0.3, minus 0.32. But if you get a value that's 2.81, what it says is it's a 2.81 normal standard deviations away from the mean. It's somewhere in this region. It's 3 standard deviations away, so it could be an outlier. It's easy to spot with this. That's basically the difference. I've done another example to try and explain this a bit more.
Sorry, so when we spot it, is it to remove it from the data completely?
That is correct. It's to remove it. That's it. You're exactly right. So yeah, I have another example with just 97 data points. And when I use the normalize, you can see everything is 0, 0.1, except for this line over here, which is 1. But because I have a large data set, and when you use a standardized function, you can see this one is what, 9.69. It's like 9 standard deviations away from the data. So it's very clear it's an outlier. When that happens, all you do is you go there and you delete it. And that's when everything else makes sense. Does that give you an example or make you understand what an outlier is and when you use normalize and standardize?
Yes, it does.
Yep. Normalizing is just to try and get a ratio relationship between the data saying going from 0 to 1, or you can change it and make it fit any range you want. For example, you can make it fit minus 300 to 300. And you might ask me, why do you want to do that? So let's give you another example. Let's say Bola went and did a maths test that's out of 200 marks. And then Emmanuel went and did a maths test that's out of 500 marks. And then Bola got 81 marks. And Emmanuel, did I say 200? So you got 181 marks. And Emmanuel got something like 420 marks. How can you say who got a higher mark or who did better? Because one of them is out of 200 and the other one is out of 500. Can you compare those two things? You can't. But what if you normalize both of the data sets? Because one of them is out of 200. You can be 0 to 200 being your min and max, and then bring it down to 0 and 1. And you get a value like 0.95 or 905 for Bola's answer. And for Emmanuel, I said it's 420 out of 500. So you go from 0 to 500 and you reduce that to 0 and 1. And you will get something like 81%, I believe. Sorry, 84%. And then when you compare them both, you can see, Bola got a value of 0.9, and then Emmanuel got a value of 0.82, 84. And you can see, Bola did a better job than Emmanuel. Again, this is not real data. I'm just giving you an example of how you might use a normalize and standardize. And this will be something that we will go over again and again, because this is something you will be using quite a lot when you're doing advanced statistical analysis or advanced analysis. All right, that's the homework complete right now. Let's go over the fundamentals of data. So last week I tried to explain different things such as structured and unstructured data.
Please, I have a question, Vijay.
Oh, yes, Amos. Go on.
Okay, concerning normalization and standardization, is it possible to do it on Excel?
Yes, it is.
Uh, so can you show us the formula on Excel? Like the function, is there a function for it?
If there is no function for it, you can still use the you can write the equation down. So right here, I wrote the equation down, which is taking the value, take from the minimum and dividing by the range.
Okay.
But if you want, you can use the where is this? Confidence intervals. Maybe Google Sheets doesn't have it. I will send you a message on privately on the normalizing in Excel, the equation for it.
Okay.
Yeah.
What about
Is that message going to come to everybody?
I can send it to everyone in the discussion.
Yeah,
Aaron, if you
to ask.
can. Sorry?
Exactly.
I was about to ask too.
Okay, Amos, if you can you ask the question in the discussion on Discord so I can reply there for everyone?
Okay.
Thank you.
VJ,
Yes.
the problem I have here is still the standard deviation. You showed us a graph there now on standard deviation, and you were trying to say if it's 2 steps away from the middle, then it's unique. I don't know, how do they arrive at that explanation? I don't know if you understand.
Yep, I understand that. And if you have some patience, I will explain that in due time because this is covered in our lecture today.
Okay.
I'm not going to forget that one. I will definitely explain about standard deviation and how we get to that value for you. Right, so let's go back to this one. I explained structured data can be in the form of numerical, text, Boolean, which is basically yes or no, and categorical, which can fall into a data set like exhausted, not exhausted, a limited set of data. So yeah, and then we can break them down into their actual values, like numerical data can be an interval data or a ratio scale. Boolean data is called a binary data because it only has 2 categories. And categorical data can be nominal or ordinal. Again, unstructured data is basically quotes, reviews, and etc. Anything that has no labels on them. So if I go over here, I keep on saying structured data always has labels on them. So this is an example of a structured data. You can see there's a clear label for this data set. That's a customer ID. Or if they're a male and female, we have the data labeled as sex. And then if they're employed or not, income, it's a ratio data, material state, marital status, whether they're married, never married, etc., what kind of house they have, etc. All of them are labeled and clear. So if you say, oh, I want to go to customer ID 6369 and find out what their income is, you can just go to this row, go to the income column, and you can see they get 12,000 value, whatever, pounds, anything else. That's structured data. But if it's an unstructured data, you can't see any of this because you have to try and read the quote and understand what it is. For example, when you're doing introductions, I said, I've been working for 4 years at a startup and I went to masters, I did a master's at Imperial College, etc. But you can't see that in a labeled or structured manner. You have to read the entire data set to understand it. That's the difference between structured and unstructured. So let's go over this really quickly. Numerical data can be the customer ID, income, number of vehicles, and age. And then the text can be anything that's not a number. A Boolean is something that only has 2 values, true or false. And you might argue that sex is also 2 values, female or male. But again, I don't want to get into that one because of the ethics, where they say there are too many genders out there. So let's not get into that one. And then we can call it a categorical data where you have multiple values for gender or multiple values for marital status like married, never married, widowed, etc. But let's go over these values. So when I give you these values saying binary, nominal, interval, ratio, and ordinal data, let's actually put them in a nice order. So there we go. If you're going towards the left, it's quantitative data, and if you're going to the right, it's qualitative data. I don't know if everyone here knows what I mean by quantitative and qualitative data. So I'll give you an example. Quantitative data is like a quantity. You can measure it. So let's look at the age. You can say 0 years old, 5 years old, 27 years old, 32 years old, 44 years old, etc. That's a ratio scale. As they go into the interval data, it's not very open. It's restricted. So because you're putting into sets like, are you within 0 to 5 years old? Are you within 5 to 10 years old? Or are you within 10 to 15 years old? Or are you within 15 to 20 years old, etc.? You're putting them into intervals. An ordinal, it can be a categorical or text-based data, but still has a it's still in a ordered manner. So you go from being a baby to a child to teenager to young adult. So ordinal is something that's compared. You can be in one field or another field, and you can know which one's higher, lower, or better or worse. And nominal is something that can't be measured. You can't say Africans are better than Europeans, or you can't say Asians are better than Africans, and etc. You can't say that. But they're all their own categories. And qualitative means it's a quality. It's not about the value of it, it's what it is. Colors are also qualitative data, etc. The reason you need to know all of these, is when you're doing some statistical analysis, you will use different techniques for each and every one of them. I will be covering them, so it makes more sense. All right, that's types of data complete. Do you have any questions about types of data? I know I gave splurged a lot of information there, but types of data are nothing but definitions that you need to remember, or you need to know, or be aware of. And then when you're doing statistical analysis, that's when these types of data matter, because you know what kind of techniques you need to use. If you have any questions, please raise your hand. If not, I will continue and I will start the actual mathematics bit here. Yep, thank you. Olufemi, thank you, yeah. Well, yeah, that's actually a good idea. If you're all comfortable with this, please do a thumbs up so I know I can carry on. If not, I will try and start picking on people to explain what's going on or ask me questions. But I get a feeling that my internet's a bit slow. Is that true? All right.
That what's a bit slow?
My internet,
Oh, okay.
because I feel like after I ask a question, it takes a good couple minutes before people respond.
Okay, maybe.
Maybe. Okay, that's fine then. Right. A lack of response, I'll take as you guys are comfortable. If you have any questions, ask me on Discord. I will try and respond there. Carrying on, data collection methods. There are a lot of ways you can collect data. I don't know if you guys have done this, but when you're in a primary or secondary school, you go around doing surveys. Have any one of you done that? Just asking people questions like, do you use this shop frequently? Do you go to this market? Do you use this path? When I was doing geography, that's what I've done. I've been to different cities and asked them questions to understand more about the foot traffic and etc. So surveys is an example of a data collection. The other one is a census data. You know, every 5 years or so, every 10 years, people come knocking on your house asking how many people live in your house. What are the ages and etc. They ask you all those questions because they want to try and get the population data, which can be a public data. And then the modern data right now is social media data that people use a lot. So when you open TikTok, Instagram, Facebook, what kind of links do you click on? When you get adverts, do you click on the link or not, etc. For example, from Amintip, when we're doing the advertisement, we use Facebook advertisements. So I don't know if some of you have seen it when we are trying to advertise ourselves about data analysis, cloud computing, etc. We use them. Those are the kind of datas. But for the purposes of a portfolio and everything, I'm not going to ask you to go out in the streets and start asking people for data. If you want, you can do that, but I don't suggest you do that. If you want, you can collect your own personal data to do it. For example, you can keep a record of how many steps you've taken every single day, or how many shops you've gone to, or how many donuts, sweets have you eaten. If you want, you can use your own personal data to do some portfolio projects. But for most of the time, we'll be using Kaggle. And I'm sure I explained this, showed you guys this last week, but I'm going to go over this one more time. So if we go to kaggle.com, I suggest you guys create a link account as well. It's useful. You can click on datasets, and here we go. You can try and use any data you want here. When we're doing an example, which I'll be doing soon, I got a dataset from there. This is a sports or exercise dataset that I got from Kaggle, and I expect you guys to try and do something similar. So that's the end of data collections. And I will go over the ethics of data collection and data analysis as a separate module, because right now ethics is very important in the data analysis section and data analysis field. So I'll try and cover that as a separate section so it makes more sense to you guys. So with that, I've finished the fundamentals of data. As you see, fundamentals of data is nothing about knowing some definitions of types of data and being aware of where you can get your data. If you work as a data analyst in a big company, most of the data will be readily available for you, so you don't need to worry about that in terms of transactions, sales, etc. So yeah, any questions? And please react with an emoji or something, with thumbs up or raise your hands if you have questions, so I know what's going on, whether I can continue or not. If you guys don't respond, that means I'll just take it as you guys are very confused. Thank you, Ayodeji. Oh, thank you, Amos. Thank you, Olafemi. Thank you, FA. Who raised their hand? Yes, FA, do you have a question?
I do.
Yes.
So I was
please.
going to ask with Kaggle,
Yep.
you're going to open an account with them, right?
If you want to, yes, because if you want to download datasets, you have to create an account with them.
Okay. And is it free?
It's free, yeah. You can use a Google account to log into that and do it.
Okay.
But yeah, there's no rush to create it right now, because once we get our statistical measures complete, that's when we'll start working with Kaggle datasets. Right, let's start with the statistical foundation. I just want to make sure everyone knows all these datasets over here, or not datasets, all these functions. Before we go there, I'll try. I showed you this graph last week because I know Emma's asked me about predictions. Do you do that with a data analysis? Yes, you do. Predictive and prescription analytics or analysis is an advanced data analysis techniques that needs to be done and learned if you want to be at the forefront of data analysis and be hired. So they will be covered in this training course, and you'll be doing some of those. But we will start with descriptive analysis, and then we'll do something in the middle that's called inferential analysis, and then diagnostic, and then we will start these two. So let's start with the descriptive analysis. Before I start with descriptive analysis, I want to make everyone aware of this one important thing. What's the difference between a population and a sample in data analysis? I know everyone's a bit shy today, so I'm going to go ahead and answer it. Population is a particular group of interest that we want to study. For example, we want to find out what kind of exercise or what's the fitness level of an average working class citizen. That's a very particular one, an average working class citizen. That means all adults that are working between the ages of 18 and 67 in the UK. That's our population. Or it can be something else. It can be a very particular one saying, I want to go and find out information about all the German Shepherds in the UK. So that's every single data about German Shepherd dogs. Or it can be very general, saying, I want to know the information about every single student that's in a school. You can use your own primary school, or you can say all secondary schools. A population can be big, small, or anything. It's just a very defined data set. And sample is a subset of the population that is ideally random and unbiased. What do I mean by unbiased? So unbiased means when you're collecting data, it doesn't impact any decisions or any information that you get. For example, when I say I want to get an information about the general population, general working population, and I go to a particular company, so let's say I go to Google and I interview everyone there. That's a small sample, but is it an unbiased sample? No, it's not, because people that work in Google are generally people from a what's the word? People graduated with a master's degree or bachelor's from a reputable university. So they're likely to be smart, and they're not a representation of a general population. At the same time, people that go there are very interested in tech. There are a lot of members in working class citizen that do paperwork. They have no interest in data analysis. They just do reception jobs. You can't get that at Google. So that's a very biased data set. In the same way, let's say you go to a not a coffee shop, you go to a donut shop at 5 p.m. when all the schools close, you see a lot of students there rather than the general average population. These kind of things are biased data. And when you're doing your analysis, you have to try and find out if there's any bias in the data or not. And how do you do that? It's by questioning it. As I said, a good data analyst will continue asking questions, try and learn more about the data, try and understand more about the data, and etc. So always question, be skeptical about things. Yep, this is a nice little visualization. A population is the entire data set, which you can never, ever measure or get data from. All you do is you get a small sample from it, and you do your analysis on that one. So yeah, with that, let's go back to descriptive statistics, where you'll be doing analysis on samples. So descriptive statistics is nothing but understanding what's happening now based on incoming data. You give very, very generalized information. So it's the first kind of data analysis that's performed. It's applied to a reasonably large volume of data. When I say reasonably large volume of data, it should be hundreds of rows or thousands of rows. It can't be one or two. That doesn't make sense. And keep in mind, description and interpretation process are different steps. And I know I said this to Ayadeji in the homework when he tried to go into an interpretation step saying the standard deviation is lower, so I expect it to be really good. You have to try and describe the initial data set saying the mean is high, the min is high, the maximum is high. That's why it's good. And then you go to the next step. That makes sense? So descriptive data is all about trying to describe what a data set is like. And then you explain what the data set means. That's what's important about this. And then I'll be breaking this down into two sections. The first section will be numerical analysis, which will be covered this week. The second section will be representation of this data in graphs and etc., which will be covered next week. So let's start with this one. The first and common one that we use is mean. What is a mean? I didn't have an animation, it's fine. A mean is an average. You're saying it's an average value that represents the entire data set. For example, I have this random data set of 8 values here. What's the average of it? How do you take an average? Is by adding all the data, which is that big sigma sign, the E, and dividing by n, which is the number of units. And the reason I put two equations that mean the same thing is to show you the difference between a sample mean and a population mean. Keep in mind, I will be repeating this multiple times, because if you're writing an analysis or writing a paper on this, not a paper, writing a review or a statement, and you use the wrong symbol people will know that you're not a good data analyst and you have no clue what you're talking about. So 90% of the time you'll be using X bar. You won't be using mu to represent mean. And similarly, you'll be using small n to define the number of data points, not the big N. The big N is reserved for the population. So what you do is you add all the data up, which is 23, and then you divide it by n, which is number of data points there, and you get 2.875. That's the average value. And you can see that 1, 3, 2, 0, 2, 3. All these values are close to 2.875. And you have 5 and 7 that are slightly bigger, which brings the mean up. But still, a mean is the value that's an approximately median value, which shows you this distribution. The other descriptive statistics is mode. What is a mode? It is the most common or the frequently occurred data. As you can see over here, 3 and 3 happen twice, 2 and 2 happen twice. So those are 2 and 3 are the most common data sets here. And then I know I'm using a very small data set here to explain this, but in reality, you'll be using a large data set, thousands of them. And mode is like the most common. For example, you go to Greg's and everyone over there buys a vegan sausage roll. That's the most common food they buy. Example, mode. When you're in a store or in a retail industry, you like these kind of datas. And generally you use mode on, if I'm linking this back to our different data sets, which is this one here, you use mode in the nominal or ordinal scale datas, in the qualitative datas, and you use mean in the ratio and interval data, in the quantitative data. That's what you do. All right, let's go. The next one is median. Median is exactly halfway point in the data set. What's right in the middle? How do you do it? The first thing you do is you take the entire data set, you arrange it in an ascending order, going from the smallest to the biggest, or you can go from biggest to the smallest. And you have 2 arrows that start counting down to the value. And then you find out it's between 2 and 3. So you take an average of those 2 values, which is 2 plus 3 divided by 2, you get 2.5. Your median value is 2.5. And you say what's in the middle. And then this is a general equation that you use for any large data sets. Suppose you have thousands of data, 10,000s of data. What you do is you take the sample number, add 1 to it, and divide it by 2. And if you get a value like 0.5, you try and find the no, not that one. If you get a value like 4.5, which is an example here, you go to the 4th position and the 5th position, take an average of it. Or if you get a value of 10, you go to the 10th position over here and take the value of that. That's what you do for the median. So yeah, that's my example explanation here. So you do 8 plus 1 divided by 2, we get 4.5. So we're in position 4 and position 5. All right, mode, median, and mean. These 3 values or measurements are used for central tendency. What I mean by central tendency is when you're explaining what a data is, this is what you use, saying, oh, when you say an average representation of a data is central tendency, where it is, what all the population or all the sample revolves around. That's why these are the strong data that you use, and it's the first thing that you do whenever you get any data sets. You try and understand all of this and measure it and see what makes sense to you. And keep in mind, you have to remember, when you're using quantitative data, you use mean and median. And when you use qualitative data, you use mode. That's all you need to know. Yes, you have a question?
So I was going to ask, because for the median,
Yes.
when we have like values now, do we have to sort them in an ascending order
Yep.
before we
every
can?
single time.
So in an instance where we have the ID to be in years, like 2023,
Yep.
2nd of February, 2023, 3rd of February, and then we have maybe say price on the other column.
Yep.
So how do we sort that in an ascending order? Because if we sort that, I think the values on the price will be changing and it won't tally with the date we have, right?
That is correct.
So how do we go about that?
So I think you're asking me a question about Ola's assignment. How do you
Yeah.
find the median of that data?
Yes.
Yeah, I understand that. So what you do is you set a time frame saying, oh, for the last 2 months or for the last 3 months, what's the median data? That's what you do. That's how you do it. You constrain the column for the time series. So when you're doing a single value analysis or a single data set analysis, you always constrain it within a period, and then you do it.
So we constrain it to a period of say 3 months or 1 year?
Yes, that's right.
Okay. So when we constrain it to a period of 1 year, then are we going to sort it out in an ascending order then?
You have to, yes.
Okay. All right. Thank you.
Does median help you in that one? It might not help you with that one. Maybe the value you want to look at is the mean of the data, saying what's the average price.
Yeah, because it talked about descriptive statistics. So
Yeah, as I said, there is a use case for every single descriptive statistics measure, and you need to know where you should use it and where you shouldn't use it.
okay.
So yeah, as I said, if you don't know, you should ask the questions, either me or Ola, and say, do we use this here, or why do we not use it here? Does that help?
Yeah.
Yep.
Thank you.
No problem. As I said, I'm here to help for this first few till you get to a reasonable standard, and then you'll be asking me questions that I can't answer down the line. Let's hope that's not the case right now. So yeah, I explained about the central tendency, saying what's the average value. Once I know the average value, when I try to compare them, does it help? So we have two.
Sorry,
Yeah.
DJ.
Yes, Emmanuel.
So median, is it more of qualitative, yeah?
Median is not qualitative, it's more for quantitative data. Yeah,
More of quantitative.
it's a numerical data.
Yeah, okay.
Yeah, you can't use that for. You can use that in an ordinal data, which is like. Let me go back on this one.
Yeah, I just want to take an example of where we can apply median.
So you can use median in interval, so in ordinal data, like this one.
Okay.
But you can't use it in categorical data at all.
Okay. All right, thank you.
Yep. No problem. Right, going back, we get to it saying. So we have two different data sets here, and if you find the mean of those two data sets, you'll get the same value. Does that help us? No, it doesn't. And I actually went a step further, and if you find the median of these two values, you still get the same value, I think. Yes, you will get the same value. Does that help us? No, it doesn't. So that's when we need another descriptive statistics. That's the variance and standard deviation. What these measure is the spread of your data, saying how far away is it from your mean. By the way, Emmanuel, I know you leave around this period for your work, and what I'll be covering is something you will have learned during your data science course. So this is just a recap for you. Feel free to leave whenever you want to. So going back to this one, variance and standard deviation is just a spread of the data. And this is the formula you use. So you asked me the question, Bola, how does standard deviation actually give us the spread and how does it make sense? So there you go. You take the entire data set, you take it away from the mean and you square it because you don't want to have any negative values. If you square a negative value, you get a positive value. And then you take the mean of all that spread based on your population size. And what this does is it always averages down to values from 0 to etc. The smaller the value, the closer you are, and the bigger the value, the further away you are.
Sorry, come again with that statement, please.
So yeah, the reason why it's the values oscillate around 0 and 3 or -3 and 3 is because of this value over here. You take the mean of the data, as you can see, the mu. I have another one as well, or x bar. Why is it? There you go, x bar. You take the mean and you look at the variation from the mean for each data point here. As you can see, every data over here, you look at a difference from the mean, and then you square it and divide it by the sample size or population size. And that's why it always standardizes, always goes together. It's just a mathematical way of doing it. And then I have an example, and then, okay, before I do that, I have an example prepared for us to go over it. But
Sorry, VJ.
yes, Emmanuel.
Sorry, I just want to take us back a bit. So I want, if the data is quantitative, yeah, in nature, yeah, is it possible then to use mean or mode, yeah, to describe the data?
You can use
Mean or mode. In fact, you can use median. You can use median, mean, and mode, yeah?
yes.
Am I correct?
That's correct. But for qualitative data, you can't use mean or median. You always use mode.
Mode, yes. For qualitative is mode, yeah?
That's correct.
Okay, I just wanted to straighten that out. Thank you very much. Yeah.
That's correct. So yeah, so this is the equations for variance. And if you square root it, you get a standard deviation equation. This is what it is. So let's work through an example. So you have the data set 0 to 7, which is 8 data points. And we know the mean of this is 2.875. And what you do is you take the value, take it away from the mu, which is our mean. And you get this data. And what you do is you square it. And the reason you square it is to try and get rid of the negative sign. You always want to try and have a positive sign there. Because if not, if you add all of this up, you will come down to 0 or close to 0, which is not what you want. So when you square it and you add all of them up and you divide it by n, which is the population size, you get 4.359. And again, no matter how spread the data is, because you're dividing it by the mean of the value, it always averages out. And your standard deviation will always be within -3 and 3. And the standard deviation for, wait a minute, the standardized standard deviation will not be, I just confused myself. I'm so sorry, Bola. The standard deviation will always change. It can be any value. It can be 10, 20, 30, or 40. It's not always between -3 and 3. It's the standardizing that's between -3 and 3, because the mean and the standard deviation is unique to a data set. That's why, because you get the mean and the standard deviation from this value. So let's look at an example from 2 and 2.875. If you add and subtract this value, which is 0.8 and 4.8, it should cover almost 60% of data, which is 1. 0.8 is over here, 4.8 is over here. So 1, 2, 3, 4, 5. 5 out of 8 data sets are being covered by this one. All right, did everyone catch my mistake that I made just now?
Yes.
Yes, the mistake I made was I said standard deviation is between -3 and 3. It's not standard deviation that's between -3 and 3. It's the standardized score, or standardized value, the z value. That's what it will be between -3 and 3, because you're using the data that's unique to the data set, which is the mean and the standard deviation.
VJ, please, I have a question.
Go on.
Is the standardized value the same as the Z score?
Yes, they're both the same.
Okay, thank you.
Standardized and z-score, they're both the same values.
Okay.
So I just want to get
I
you.
guess that there is a formula for calculating the z-score.
Yes, the formula to calculate the z-score is right here, which is based on the mean and the standard deviation. Sorry, Bola, I didn't get your question. Is that what you wanted to know?
Yes, correct. Yes.
Yeah, because you're using the metrics that are unique to the dataset, the value will always fall between -3 and 3. All right, let's go back to here. I have another one prepared for us. Spoiler alert. Anyway, so now assuming these both are the same dataset, they both mean the same thing. If you look at the mean of the data, they're both the same, but the standard deviation between these two datasets are different. The standard deviation for the first initial data is 2.088, and the standard deviation for the second dataset is 14.9 or 15. So what does that mean? The first data is very closely packed with each other. The second data is quite far spread away. It's big, it's large. So that's how you measure the spread, saying if you get any data from the first set, you can be confident they will be close to each other. But if you get anything from the second set, you know they won't be close to each other, they'll be further away. And then there might be some other data that's like, that says the standard deviation is like 1,000. That means you're definitely sure it'll be very far away from each other. And then that's it. Does anyone have any questions about this one over here? If you guys have.
My question is, does this answer the question that Efe asked earlier, that the closer, that she wanted an explanation on what you meant by the closer the standard deviation, the more closer you are to the answer, or something like that?
Yes, that's the value over here. So once you get a mean value and look at the standard deviation, the smaller the standard deviation, the closer it is to each other. And then the higher the value, the further away they are. And the question that you asked me is, how can you be confident that it will always be one standard deviation away is 60 or 70%, when two standard deviations away is, let me get a bigger graph, is 95%, and three standard deviations away is 99%. And the reason being, if it's a normal distribution, if it's a normal distribution, based on the unique values that you get about the standard deviation and the mean, it will always work out mathematically. And if you want, there is like a 2-page proof, a mathematical proof to explain this, but I don't think it's required in this stage, or it's required to be a data analyst. It might be useful for a data scientist or a mathematician, but not for us. But if you're keen about that, I can link you the paper and explain why it is such a value. So anyway, going back to this one, to reiterate, because we're using unique characteristics based on the data, which is the mu and the sigma, mean and the standard deviation, because we'll be using the mean and the standard deviation, it will be unique, and then we can always rely on it to fall between -3 and 3. And yes, FA, if you have a question.
Yeah, so now, does it mean when we have a problem to solve,
Yes.
we don't have to interpret the solution using a standard deviation then?
No, you do. When you're comparing two data sets, you always interpret using standard deviation. So that's the difference. Standard deviation is sigma, standardized is Z. You don't need to interpret using the Z value, you'll be interpreting using the sigma value or the S value. Does that answer the question?
Yeah, that's fine. Yeah.
Yep. So standard deviation and variance tells you how far away or how close the data is to the mean. This is an important thing to know because doing advanced metrics or advanced analysis on this always uses standard deviations. So one thing you can try and do is when you're doing OLA's work, if you look at the mean for a period of time for the last 6 months and last 1 year, and you look at the standard deviation of it, you'll find out that the majority of the value always oscillates between, or the majority trend always oscillates between plus and minus 2 standard deviations away from the mean. And then if you're comparing two of them, for example, Facebook and Amazon, you can look at the standard deviation for the last 2 years, and you can see whether it's being constant or not. If it's not constant, and if it's volatile, that means it might be a bad thing. And it might be a risky, so you can make more profits or you can make more losses. So anyway, back to this one. Do we have any more questions over here, guys? Yes, FA. What's the question?
Sorry, I'm on mute. Yeah, I was going to ask a question because you just said something concerning Ola's assignment. So, in an instance where we have in a particular year, 1 minute. Where we have we've done the calculation for the whole year on a yearly basis, and then we have the standard deviation. Can we say from that value what can we predict, or can we say from that value can we analyze from that value what it is with the standard deviation we arrived at on a yearly basis?
Yeah, you can say if you're comparing two data sets, Facebook and Meta, again, looking at the standard deviation, you can say which stock has been more consistent, because the smaller the value, the closer it is, and it's more contained. There are no volatility, or there are no major changes. But if you find out the standard deviation between those two data sets is very high, for example, Facebook is like 1,000 units, and then Amazon is like 10 units, you can say that Facebook or Meta is 10 times more volatile than what am I saying? Than Amazon. I keep on forgetting the names. Yeah, that's how you compare them. But if you want, you can do a standardize. You can standardize the entire values there. Which, when I say standardize, you can use the z value to look at it. If there's any value that's bigger or less than 3, or is smaller than -3 or bigger than 3, you can see, oh, there's a period where you're getting extreme data. Anyway, I feel like I'm giving you too much answer for your assignment that's due Sunday, so I'm going to shut up.
All right, thank you.
Yeah, I'll be very clear, because I know people have been saying, based on last week, I know everyone wants to learn and know more about it, so I'm more than happy to do this now. But down the line, when I start setting difficult assignments, you will be getting less help from me. You will just get more and more questions from me whenever you ask me a question. All right, enough of that. Let's go to the next one. So what we went through is mean, mode, and median as a central tendency, and then we did standard deviation and variance for a spread. But again, standard deviation and variance are not the only ones. You also have something like range. What is a range? It's nothing but maximum value take away minimum value. So over here it's 7 minus 0. So it's 7. That's the range. The reason you use the range is you can find out what is the extreme ends of the data set. But again, you have to be careful here. So if you have a outlier, you have to try and remove it before you calculate the range. If you don't remove it, then you will get an extreme extreme value, or not extreme. You get incorrect answer. That's why you should be careful with outliers. The next one is quartiles. So you have all these things. You have 0%, 25%, 50%, 75%, and 100%. The reason you use quartile is saying, oh, 25% of the data is between 0 and 25. 50% of data is between 25 and 75. You can try and explain those things. And rather than using the extreme values, 0 and 100, you can try and use the lower quartile, which is 25%, and upper quartile, 75%, to describe your range. And you can be sure that you're avoiding all the outliers. Because if 25% of your data is an outlier, that means it's not an outlier. Does that make sense, guys? Because if, like, let's say out of 50 values that you get, you can't have 10 values that are an outlier. It will become a trend if that happens. So yeah, there we go. How do you calculate these things? You can calculate a 0% value by taking the minimum value, 100% by taking the maximum value, and 50% range or quartile by taking the median value. So any ideas on how do we calculate the 25% and 75%? How about this? Whoever answers me this question, I can give them some help with Ola's coursework.
I like that. That's a bribe, right?
Not fair. Not fair.
I need to get you guys to answer and interact with me. So there we go.
I would say, what if I divide the median into 2 again?
That's a good
And I
point.
get 25%?
That's correct. Is there anyone else have any other ideas? Valentine?
No.
No?
No.
You unmuted yourself. So I thought you might talk about it.
Oh, okay.
That's fine. So yeah, Effie, you're absolutely correct. So over here, we know the median values right there. So what we can do is we can divide this data by 2 again, and then try and get the value in the middle of it. So there's 2 over here and 2 over there, you can get the value. That's correct. But that only works if it's a very small data set. If it's like thousands of data, are you going to sit down and divide them in 2 and look at it? You won't be looking at it that way. So you have to use a different thing. You have to use a formula. And before I do that, let me just clear everything. So yeah, everything. There we go. So what you can do is you can use this formula, get rid of this. You can use this one, where n is the number of samples or the sample size. You add 1 to it, times it by the percent that you're looking at, and divide it by 100. So yeah, this one, you times it by 0, divided by 100, you get a 0 value there. You times it by 100, divided by 100, you get the sample plus 1, which is basically meaning to take the maximum value. And then within these 3, you can use the same sample or equation. If you look at the middle one over here, which is, if I do the same thing again, annotate. If you look at this one, let's try and simplify that. So you have n plus 1 times 50 divided by 100. That's basically another way of saying 1 over 2. N plus 1 times 1 is just n plus 1, and n plus 1 divided by 2. What does the equation look like? The equation looks like the same thing we used to calculate median, which is right here. Oops. Where is? There you go. N plus 1 divided by 2. Same equation right there. There, all good. Let's go back here. So that's what you do. And then when you get them, you find out the positions. 0 is the first value, 100 is the last value, 50 is the value in the middle, 75% is what you get for this one is you get 6.75. But whenever you get 6.75, 6.25, any of the 2.25, 0.5 or 0.75, always calculate the value that's between these two. And in the same way, because if you're looking for a 25% value, you'll get 2.25, which will be between 1 and 2, and you take the average of that. You don't try and take 25% of the value from one and 75% away from 2. You don't do it that way. You just take the middle calculations. The reason you do all of this is also you can get an interquartile range, which is 75% minus 25%, which contains 50% of the entire data range, which is between these two. And you can be confident that it doesn't contain any outliers inside it. While range is susceptible to outliers, interquartile range is not. So today we went through all the basic descriptive statistic measures, which is the range, mean, mode, median, quartiles, standard deviation, variance, and interquartile range. before we go any further, I do want to say,
Sorry. Can we say interquartile range is used to remove outliers? Can we conclude that?
there is a trick where you can use an interquartile range to get rid of the outliers, but what we can say is interquartile range is not susceptible to outliers. So if you have outliers in your data, interquartile range will not be impacted by it. That's what you can say. So if your
Okay.
data is very messy and it still has outliers, it can still be confident that interquartile range will give you a reasonable range value.
Okay.
That's what it is. So yeah, one thing I want to mention is the quartiles. You don't have to do 0, 25, 50, 75, 100. You can do any values that you want, any jumps, 0%, 10%, 20%, 30%, and you can compare them between each data sets, saying, the lower 10% of this data set is still higher than the other 10% of the next data set, and etc. So it's all about how you use these measures to explain your data. That's what a data analyst does. Everything they do is very simple and straightforward, which is using all these statistical data. And then they will go from there and then try and use it to describe and compare data sets. So before we do that, I just made a note somewhere that I want to read one more to myself. No, not that. Not that. Oh man. Right, that's fine. I was just going to give you an introduction to what we will be doing next week. Next week is we will be doing the same thing, but instead of looking at this mathematical ones, we'll be looking at graphical. We will be creating graphs and etc. to understand more about this. So yeah, the homework is go over all the descriptive analysis equations that I introduced here. I want you to try and remember it and try and understand it. And I will provide you guys with a worksheet in Discord so you can try and use the data or use the equation that we learned here onto it. So yeah, any questions about these guys?
Yeah, Vijay, please.
Yes, Valentine.
My question might be weird, but I just want to understand something.
Okay.
Referring back to the assignment, let's say the question 1, question 2, question 3.
Yep.
Now, I wanted to ask before this lecture, how do you know you are going to use mean? You are going to use mode, you are going to use range, you are going to use standard deviation to answer each of those questions.
How
I
do you
wanted to ask that question. Yeah, I think the lecture talked about it. I don't know if you can still brief a little bit on that aspect.
Yeah, that's fine. I can do that. So that's a very good point. The question is, if I understand this correctly, how do you know what statistical measures can be used here? That's the question.
Yeah, sure.
And my answer is, we don't. It's all based on experience. The more you try and do this, the more you understand about all the statistical measures that can be used over here. I use the most common ones, which is the mean, min, max, and standard deviation. If you want, you can use the interquartile range as well, I believe. Nope, IQR. I hate the fact that it doesn't have it over here, but you can do equal to quartile and then take the data for, let's say, Kaizen, select everything, and you say, I want the 25% quartile. That's not how we would do that. You do 0.25, 0.25. You can do that, and you can do your own analysis there. So I don't know if I answered your question, Valentine, but the answer is you don't know that one, but you try and use everything that you know till you find something that explains the data set to you.
Okay, you just with experience, you just assume, okay, we can use mean to get so data for this question, something like that.
That's correct. Yeah, you try and experiment with everyone till it makes sense.
All right.
Yep.
That's fine.
All right, guys. that's the end of the
Um,
course. No, go on. What's the question, FA?
yes, I was gonna ask a question. Where is it?
Please do.
In an instance where we have to show maybe like a time series or something, or using this descriptive statistics again. Now let's come back to that. So in a graph, can we show standard deviation against year, against time? Is that possible?
Ooh, what you're asking is a slightly higher, well, advanced question, but because you did get the interquartile range solution correct, I can give you this answer.
Thank you.
So if you want to impress, oh wait, everyone's going to hear this one. That's still fine. So if you want to impress Ola with this one, what you can do is you can break down your data sets into different months. So January, February, March, April, etc. Or you can do based on the last quarters, like last 3 months or 3 months before that and 3 months before then, etc. And what you can do is you can take the mean of those months. So let's go with a blank space. I can actually explain this better. And then do this one. Okay, as I said, this is quite an advanced one. So if you do it, I think Ola will be very impressed. So you have Q1, Q2, Q3 in a year. It's quartile is the quarters, and Q4. So this is January to April, March to, I can't do my maths correctly, January, February, March for the Q1, April, May, June for Q2, June, July, August, September for Q3, and October, November, December for Q4. What you do is you get the mean for all of these values, and then you get the standard deviation for it. And in a graph, you can be like Q1, Q2, Q3, Q4 for whatever years, on the years before that. You can plot your data set for X over here. X bar, sorry, that's X bar. Like you get something like this. And then what you can do is you can use the standard deviation S to get your standard error, saying how it was different during that period. What kind of range it's moving by. So you go one standard deviation above, one standard deviation below, and say 70% of data showed this trend. Does that answer your question? Like, how do you show this? As I said, it's a bit of an advanced one. So if I were to use a different color, if I can. So yeah, these data point over here will be X bar. And then these extensions will be your standard deviations. So that's how you can use to show in your graph. If not, you can go with an easier one, which is to plot the range of it, the maximum and the minimum there. So if you look at some of the stocks, market shares or whatever, you will get something like this. This is not your box plots that you know from schools and everything, but rather this is the high value, low value, opening and closing, or the other way around, depending on whether it's shaded or unshaded. You can do that. These are the different tricks. But this one is an advanced one, which is basically plotting the error labels by using standard deviations, also known as standard error. Yeah, does that help, FA?
Yeah, that's fine. Yeah, thank you.
But if we are to the data is large, it's a 5-year data. So if we are to do that quarterly, I'm trying to see how we can fit all that in to the 5 years, and we have different graphs.
So can it not work for yearly?
If you're doing it for 5 years and you're doing it for each year, that means you only have 5 data points. 5 data points is very tiny. A graph doesn't show any trend with 5 data points.
Oh, okay. Then if we do it for 6 months each?
That's still 10 data points. You want at least 20 to 30 for it to make sense.
Oh.
So you do it for each month or each quarter. But if you want, as I said, this is just a trial one that Ola said to you guys. So you can do it for 6 months and see what you get.
Sorry, just wanted to ask though. I understand, the standard deviation and all that, but comparing the two data sets to one another using standard deviation, how do you bring it, the point of comparison?
Yep. So what is a standard deviation? It's the measure of spread, saying how far away is it from the mean. So let's say you have a data value, a mean value right here, another value for mean right here. Both of these values are very close to each other, right? Olufemi, I'm talking to you. They're the same. If you're looking at this bar, if they're very close to each other, you can see, or the average for those two are the same.
Okay.
But if the standard deviation for this one is only this big, and the standard deviation for the other one is this big, what can
Okay.
you say? The spread of the second data is
Okay.
larger, is bigger, it's more volatile, it changes a lot compared to the first one.
Okay.
So what you're trying to say is how close it is to the mean rather than how far away it is. That's what you do.
Okay.
Yeah. Right. So we have two options here. Right now, I haven't finished setting you all in homework because I want to be like Ola and give you all individual homeworks rather than give you all the same ones.
Okay.
So what I'm going to do is I'm going to try and get some questions together and send it to you guys on Saturday. I'll send it to you on Discord.
Then
But go on.
yeah, Vijay, I was gonna ask something because I had difficulty. I was gonna do a box plot. I don't know. How do you do box plots on Google Sheet? What is box plot? Maybe I should start with that first.
So box plot is something that you use to plot interquartile ranges. So it's just another way of showing the data set. So in a box plot, you always, I was going to go over this again next week, but I can do it now. That's fine. So a box plot always has the value, a tail, a box in the middle, box and whiskers, or that's what we call it, and then a whisker over here. So this one over here is maximum. This one over here is the 75% value. And then you have the median value and the lower quartile range and the minimum value. That's what you get over here. And then the question about how do you plot a box plot in Google Sheets? Let me get some data generated for you so I can actually show this one. Sorry, 1 sec. I'm going to stop sharing and then restart the share. By the way, I was going to ask you, should I go over a data set to show how we use all the descriptive statistics on them? Do you want me to do that, or are you guys busy with what Ola is doing?
Yes, please use a data set.
Use a data set, that's fine.
Okay, then I'll do that. Oh. Let me set this up properly so you guys can see this. So can you guys see everything there? It should be showing you a data. So over here, this is the data showing you for 3 different exercise machines, which are labeled TM195, TM498, and TM798. And then the description of all the users there. So the age of the users, how many years they've studied, their gender, their marital status, how many others they've used it, and what they think the fitness level is like. It ranges from 0 to 5. And then how much money they earn and how many miles they've ridden on the exercise machine. So let's go over everything I explained. So in a Google Sheet, how do you get the mean? So let's go over the income data set. Let's ignore everything else for now. So let's just use the income data set and do everything there. So if I were to open my slides, let's do every single one of them there so you know how to do it. And I'll also show you how to plot the box plots while doing that. So the first thing we did was equals to mode. And then if you do that there, what do you think we'll get, guys? Is there any value that will be repeated multiple times there?
Yeah, it's possible.
It's possible. It is possible, yes. There is a value that repeats of 4580, but it's very rare. So what you do is you always try and group it together. You do it by using a round value. What rounding does is how many places you want to round it to. And I want to round it to the nearest 1,000. So I do -3. It's a function. You're rounding this value to the nearest 1,000. So if you're getting any values, let's autofill it. So if you get any value between 29,501 and 3499, both of them will round to 30,000. So you're putting this into an interval data set. So what you're doing is you're converting the ratio data into interval data. Does that make sense?
Yeah.
So it's just a technique. You're just rounding data to convert a ratio data into an interval data.
So what if we have the values in hundreds, like 165 point something? So are we going to round it up to, is it going to be like round up using 2?
It depends on what you want to do though. Are you calculating mode and etc.? If you're calculating, then if you're calculating mode, do it. If you're not calculating mode, don't do it.
Okay.
So yeah, mean equals, we use the function equals average of the L column, which is equals average of this entire thing. And then median, I don't know if median exists. Let's see if median, oh, it does exist. So median of this entire row again, which is basically equals to median dot. And then you can do mode using the same value, saying equals to mode of this entire thing. But to me, that's not correct because it only works. Let's just do that. Doesn't always work as getting the same value to the same unit is rare. So convert to an interval data set using the round function, which is what you do over here. By the way, guys, if I'm going a bit too slow or you think this is not required, please tell me to stop. I'm more than happy to do that. Interesting, you get the same value, 45,000. So if you go here, you get 45,000 is the most common one. And if you want, you can even convert to the nearest 10,000 and then see what happens. And then let's see what you get. You will get to 50,000. That's your mode value. Anyway, that's the 3 central tendencies done. Let's go over the variance and standard deviation. All right, so for people that are listening here, standard deviation and variance.
Variance.
Yep. So when using standard deviation, do we use the STDV A or do we use standard deviation P? What do we use?
We use the P population, right?
No, that's wrong. Because did we measure, do you think we got a data set for everyone that used the product, TM195?
Mm.
No, it's impossible to get a data set for everyone that used the TM195. So what you use is you always use the standard deviation dot S for sample. So BD always use the standard deviation for a sample.
So VJ, are we using the one for the sample because there's a tendency that we didn't get all the data for all the people
Yep.
who used it, right?
That's correct.
So in terms of stock, is it going to be the same?
Yeah, if you're doing it, you have to do this. For stock, no, you don't have to. Because if you're only comparing for the last 1 year, that means you have all the data set there. So you don't have to do it for the entire, you don't have to use the sample there.
Okay.
Because if your population is for the entire 1 year period, then use the population standard deviation. Don't use the sample standard deviation. Yeah.
Okay.
And the formula over here is equals d e dot s. And the same thing over here, the formula over here will be variance, VAR dot S. Don't forget that. Equals VAR dot S. So yeah. Let's just check. In the equations that I've shared, I mentioned variance or standard deviation is nothing but standard deviation is the square root of variance or vice versa, which is variance is the square of standard deviation. Where is it? There you go. Variance is square of standard deviation. So we can check this quickly by doing square root of this one. Do we get the same value as above? Yes, you do. There you go. All right, what's the other ones that we said we did? We did range, quartiles and interquartile range. That's what we'll be doing now. So you do range, which equals, let's see if they have the range function here. Range, they don't have that. So what you do is you do max of that minus min of that. That's what you do. Oh, before I go any further, I need to make this note. I think Google Sheets always uses standard deviation to be the population equation. And Excel and everything else, yeah, that's right. No, that's not right.
No, Google Sheets got.
Sorry?
Google Sheets got the different ones as well.
Yep, Google Sheets default standard dev equation uses the sample dataset function. That's what it does. You have to be careful because some functions, I don't know if it's Excel or numbers from Apple, the standard deviation equation or default one uses the population dataset. So you have to be aware of that. All right, next go is with the range. The next one we do is quartiles. And that will be 0%, 25%, 50%, 75%, 100%. We do equal to, you can do let's see, quartile of this data, and then you do a ratio of 0. And then you do the same thing for the remaining ones as well. But instead of using 0, you use 0.25. 0.5. Yep, that's right. And then this one will be 0.75. Yep, or 1. Huh. Can you guys see something that's weird over here? All these values are the same. So let's see what happens if I try and plot this. Insert chart. Something's going wrong. Was it 25? No, it's not. Let's read what it says. The value quartile. Yeah. So it seems like I was wrong. So there you go. You should see. You should always try and read the syntax. So 0 is a 0%, 1 is a 25%, 2 is 50%, 3 is 75%, and 4 is 100%.
Okay.
So we actually use 1,
It's
2, 3, and 4. There you go. But I hope everyone else is saying that how do we go about looking at the equations or the formulas data sheet, or not data sheet, it's just trying to understand the syntax for it. And then let's check if they're the same as min of the entire data set. This and the max. Anyway, I think most of you are waiting for this one thing, how to get a box plot out of this data. So you get the entire data, you click on insert, insert chart, and then you scroll down here till you see a box plot. There you go.
okay.
It's 5 columns. Okay, what it says 5 columns. That's fine. So rather than doing it this way, you want to try and have it like this. You're transposing it. And then you select this data there. We start from the top. So you go to insert, chart, and you change your chart type to candlestick.
Must be test.
Yep. 1 second, guys.
Five columns.
Yeah, exactly what's selected here.
1, 2.
That's 6 columns, but
Yeah.
no, that's correct. 5 columns. Right. I know what's going on here. This is a good thing because this is the first time I'm seeing this as well. Like, what the heck?
Yeah. Says only one provided.
Let's look at an example. Google Sheet box plot.
Box plot. Okay.
Oh, that makes sense. So this is not a box plot, but a candlestick diagram. So you don't care about the quartile range at all. You don't care about the median value. There you go. You see Bola or FA that was talking.
Yeah.
How you get that?
So I didn't really get what you did there.
So let's go with this again. So I personally want to keep that in case anyone else wants to see it. One second, I will do this. I take it everyone else didn't follow what I did either. Is that correct? How many people are here anyway? Everyone's here, nice.
Valentine is sleeping.
So, box plot and Google Sheet. You need to have headings, minimum,
Okay.
maximum. That's not maximum. You need a 25% and
Okay. 50%.
70. Nope, not 50. You don't want 50%. Want 75% minimum equals min of this data set there. And you get quartile of L1, quartile of
Three.
L2, not 2, sorry.
Yeah, 3.
You do 3 because 75%, and then you do maximum of L. And then the heading is income.
Okay.
Let's go over and do something else. No, let's do age and education rather than income. So that's C and D. Age, education.
Okay.
So dot C. E. No, that's not C, that's B and D. What am I doing?
It's D.
B is B. B. Need the same over here for D. Select all of that, click on insert, and you click on chart. And you go to customize, chart setup, chart style, and you scroll down to box plots, and there you go. You can title it
Okay.
box plots.
Box plots.
That's it.
Yeah.
So, any question, guys?
No. Yeah. Box plot.
Right. So I have two things for everyone here. One is to go on Discord and then introduce yourself, finish introductions. And two, give me a feedback because I know I went a bit very slow today. So for people that have experience in data analysis, so I'm looking at Olufemi, Ayodeji, and Amos. I want to know whether I'm going a bit too slowly, wasted a lot of time in doing this or not. Do you guys hear me?
Yeah, that's fine.
Yeah, VJ, for sure, I can tell you that I enjoyed today's lecture.
Yeah.
And the way you broke everything down, I'm happy and impressed about it, really.
Thank you. But again, if you give me any feedback on improvements, that'll be really helpful for me.
This is fine for now.
No, but because I spend more time doing this today, that means I will be speeding up down the line. I have to speed up.
As long as we understand what you are saying or what you are teaching. Because I think the fundamental is very important. If we miss that, then there's no way we'll be able to follow you when you speed up in future.
Yes.
Yes, that's good then. Olufemi, were you about to say something? I've seen you unmuted yourself.
Yeah, I mean, yeah, for quite a number of, I mean, huge part of today's class, I wasn't actually in the class, but I'm still going to go through the playback. But I can say, yeah, it's not bad. It's okay. I did quite I do understand some part of it, so yeah. Yeah.
Okay, because most of if you've done this before, a data analytics or data science course, this is something they'll teach you right at the beginning, and they expect you to know most of the time. Yeah.
Right.
So guys, one more time. If you don't give me any feedback on how to do anything, I'm gonna keep doing it the same way I'm doing, and that's not a good thing because I need you to look. I need to know what you guys prefer so I can tailor the course for you guys rather than just doing it for the sake of doing it. All right. With that, I'm gonna.
Like what you are doing for now.
Yeah.
Thank you very
I'm
much.
impressed with what you are doing for now. I'm hoping that Ola will follow suit because we are really going to tell him, you know, pending on the outcome of our class with him on Saturday.
Yeah, Ola wouldn't. Ola understands that there's a lot to cover. That's why he's trying to speed things up. He wants you to. He wants you guys to learn and attempt it on your own. He comes from the good background too. But anyway, we both have different styles of teaching. If I slow down now, that means I'll be speeding up in the future when I'm going over the complex stuff. Just giving you a heads up.
Yeah, and if we're having issues, we'll definitely let you know. And I'm sure you would still look for a way to come down to our level. And you can be rest assured that we also are not sleeping. We are
Yes.
in our efforts.
We are putting in more effort.
I must tell you a lot of it.
That's what I like to hear. And yes, guys, if you have any questions about any Google Sheet formulas, anything, please do ask in the Discord channel because we're all working together here. So if anyone gets stuck and when you help them, that means you're learning too. So yeah.
Yeah, sure.
Good. With that, I wish everyone a good night and happy weekends. See you all again next week, and expect some homework from me on Saturday. Bye, guys.
Thank you so much.
Thank you.
All right. Bye. Thank you.
Bye.